Hello everyone, my name is Rafael. I'm an electrical engineer, and in this video I would like to invite you to see the solution of an exercise addressing the use of a BJT in an amplifying stage. The idea here is to find the voltage gain of this amplifying stage. Let's do it. The DC analysis of this circuit will be, take a look at this, okay? We can see that VC is equal to 100 kilo ohms times IB plus VBE, okay? VBE is the voltage from the emitter to the base, and you can see that the emitter is grounded, and VC is the voltage at the collector, okay? And this is normally 0.7 volts, all right? Then this expression gets reduced to VC equal to 100 times IB plus 0.7. Alright, let's skip it because we're gonna use it. The emitter current, i.e. the emitter current, is given by I E is equal to 13.7 volts. This voltage here, 13.7 volts, minus VC divided by this resistor here, okay, whose resistance is 12 kilo ohms. All right, and this is approximately equal to IC. All right, and we know that IC is equal to 1 plus beta times IB. Okay, we're gonna use these expressions. Now talking about IB, let's calculate IB, okay? It is possible to state that 13.7 volts minus VC divided by 12 kilo ohms is equal to 101 times IB. Okay? Beta is 100, 1 plus 100, 101. Okay? We are going to use this, alright? And developing this, okay? We're gonna use this here. It is going to be 13.7 volts minus 100 IB minus 0.7 volts divided by 12 kilo ohms, which is equal to 101 IB. Okay? The only variable here is IB. Okay? Simple algebra, developing this, we find that IB, I'm gonna put it here, okay, because we wanna keep it. IB is approximately equal to 0.01 milliamperes. All right, this is the result of the DC analysis. Now we are going to go to the small signal analysis. The small signal analysis is going to be the conversion of this into its small signal model. Let's do it. Let's do this conversion. Wait a minute, because I'm going to draw the circuit on the board. This is the small signal model. Okay, using this model, we are going to calculate the values of the parameters, okay, to find the gain, what we wish, the voltage gain. All right, the values of the parameters can be calculated as R pi equal to VT divided by IB, okay? This VT here is the thermal voltage, and you can find this data in the data sheet of the amplifier, okay? The transistor BJT is going to have a data sheet. You can find VT in the data sheet of the transistor, which is going to be equal to 25 milliamperes, sorry, millivolts, divided by 0.01 milliamperes, and this is equal to 2.5 kilo ohms. All right, we already know this parameter here. We are going to find the transconductance gain. Gm is going to be equal to beta divided by R pi, which is equal to 100 divided by 2.5 kilo ohms, and this is 0.04. All right, and now we are going to apply KCL at the output node. at the output node. Okay, we're going to apply KCL, and then we get that V0 over RC plus GM V pi plus V0 minus V pi divided by RF has got to be equal to 0, okay? Has got to be equal to 0. These are the currents. The currents that flow to this side, and this side. VO divided by RC is the current here. GM V pi is the current here. And VO minus V pi over RF is the current there. And the sum of them all has to be equal to 0. Alright. And we have the values of RC. RC is 12 kilo ohms. RF is 100 kilo ohms. And GM we calculated 0.04. And if we develop this and substitute these values here, we find that VO is equal to minus 428.72 times V pi. Okay? This is the result from this. Keep this, we are going to use this now. The subsequent step is to apply KCL again, but at the input node. Okay? We're going to apply KCL at the input node. VI over RS is equal to V pi over RS plus V pi over R pi plus V pi minus VO over RF. Okay? The current that goes up here, this current here, is equal to the current that goes down here, which is V pi. V pi is here. Okay? V pi. Okay? V pi over RS is this current here. V pi over R pi, okay, is the current that goes down here. And V pi minus VO over RF is the current that goes in that direction there. And the sum of them all, the sum of these currents here have to be equal to the current of this current source here, okay? And developing this and using the values of RS, R pi, okay, RF, we get that VI is over RS is equal to 5.1 times 10 to the minus 4 times V pi minus VO over RF. We are going to use these two equations here, okay, in a system to find what we wish, which is VO divided by VI, which is the voltage gain. Using these two expressions here, we find that VI over RS is equal to minus 5.1 times 10 to the minus 4 over 428.72 times VO minus VO over RF. Using the values of RF and RF, we get that VI is equal to minus 1.19 times 10 to the minus 6 times VO minus 1 times 10 to the minus 5 times VO. And here VI over 10 times 10 to the minus 10 to the 3. Okay, here 3 positive. Here negative, here positive. 10 cubed. And developing even more, we discovered that VI is equal to minus 0.112 times VO. And the voltage gain is equal to the magnitude of VO over VI, which is equal to, I pass this dividing, and then I pass this dividing here, and we get approximately 8.93. Okay? This is our result, the result of this exercise. The voltage gain of this amplifying stage with a BJT is 8.93 volts per volt. Okay, my friends, this was the video that I wanted to make. I hope you guys liked it and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!